The average August temperature in Exeter is 20 degrees Celsius, or 68 degrees Fahrenheit. The average January temperature in the same place is 9 degrees Celsius, or 48.2 degrees Fahrenheit. Part A. Find an equation linking the Fahrenheit and Celsius in the form F equals AC plus B. So the F is going to be like my y coordinates here, and my C is going to be like my x coordinates. The A is going to be the equivalent of the gradient, and the B is going to be the equivalent of the y-intercept. So let me take these points and write them as coordinates. So 20 degrees, that's my x, 68 degrees Fahrenheit, that's my y. And then we've got 9 degrees Celsius, that's my x, and 48.2 degrees, which is my Fahrenheit, so that's the y. So therefore the gradient will be the change in the y divided by the change in the x. So let's do that. The change in the y, so 68 minus 48.2, divided by the change in the x, so 20 minus 9, and we get 9 over 5. So I can now say that F equals 9 over 5C plus B. And to work out my B, I can substitute either of those original coordinates in here. I'm going to substitute the 20 and the 68. So I can say that 68 is equal to 9 over 5 times 20 plus B. And I find that B is 32. So this is my equation that's linking the temperature in Fahrenheit to the temperature in degrees Celsius. Part B. Interpret the values of A and B. Well, remember, A is the equivalent of my gradient. So what that's saying is as the temperature in Celsius increases by 1 degree, the temperature in Fahrenheit will increase by 9 over 5, or 1.8 degrees Fahrenheit as a decimal. Temperature in degrees Fahrenheit increases by 9 over 5. That's what the A means. That's my interpretation of what the A constant there means. Because it's a gradient, it's saying as the x, or degrees Celsius, increases by 1, then the y, in this case Fahrenheit, will increase by 9 over 5, or 1.8 degrees Fahrenheit. The B, remember, that's the constant on the end here. And what that's saying is the temperature in Fahrenheit is 32 degrees when the temperature in Celsius is 0. The temperature in degrees Fahrenheit is 32 when the temperature in Celsius is 0. So those are my interpretations for the values of A and B. Part C. The highest temperature recorded in the UK was 101.3 degrees Fahrenheit. We need to calculate the temperature in Celsius. So in Fahrenheit, 101.3, and that's equal to 9 over 5C plus 32. If we take the 32 away from both sides here, then we find that 9 over 5C is equal to 69.3. times that by 5, and then divide it by 9, and we find that C is going to be 38.5 degrees Celsius. So that is the maximum highest temperature recorded in the UK. And then finally part D. For what value is the temperature in Fahrenheit the same as the temperature in Celsius? So for what temperature is Fahrenheit F equal to Celsius C? So I can either now just make F equal to C, or I can make C equal to F. It doesn't really matter, it's entirely up to you. I'm going to say that my Fahrenheit is equal to Celsius. So the Celsius is equal to 9/5 Celsius plus 32. If I take C away from both sides, 9/5 C take away C is 4/5. Subtract the 32 from both sides. Divide both sides by 4, and then times both sides by 5. I find that the temperature in Celsius and Fahrenheit is 40 degrees. So when the temperature is 40 degrees in Celsius, it is also, minus 40 degrees in Celsius, it is also minus 40 in Fahrenheit as well. The fact that we've made the Fahrenheit equal to the Celsius and then solve that equation means that when the temperature is minus 40 degrees, it is the same temperature in Fahrenheit and Celsius.